So in the last video, we looked at how we might go ahead and implement a conditional system of traffic lights where if someone presses a button and the light is red, then it will stay red. Otherwise, if they don't press the button, then the light will change to green. The light's green, then if someone presses the button, then it will change to red. Otherwise, if no one's pressing the button, then the traffic light remains green. So express that in terms of a state transition diagram here. And then we went on to have a look at how we might implement that in hardware. We discussed how we could generate a one-hot signal used to control the red and green light by using this system here. And we're going to go ahead and implement that in module sim. So the first thing I'm going to do is set up the demultiplexer for the one-hot encoding. I'm going to feed a 1 into that. I'm going to use not split mergers, fan outs to compare the two. Well, this will be the red light and this one will be the green one. We're also going to need a switch of which the least significant bit will be the our button 1, and we're going to need a logic unit to perform a NOT and some registers to store the current state and the previous state of the system. So if I hook this up here, this is our button that we can flip between. I'm going to need a clock to enable and, well, alternately enable the two registers. And hang on a second, I'm just trying to think how this should be implemented. So as we said before, S is just not B, so we're actually going to pass this in to the first. I don't think we actually need this second register, so maybe we can just go like this, and if we slow this simulation down somewhat. Yeah, so we pass this into the demultiplexer, or we should be able to control it, and as you can see, it's selecting the wrong inputs because we're only interested in the least significant bit. So what we're going to have to do is put some shifts in there to get rid of all these bits up here that we don't actually care about. So we can use a right shift and a left shift and hook the control inputs together and shift stuff by 3 places. So yeah, so we shift left by 3 places, getting rid of the top 3 most significant bits, and then we right shift to bring that bit back down. So now, if you know the button's pressed, and if we slow this right down, so if the button's pressed, then the red light's set. Now if we turn it off here, then this is turned off. The red light is then deactivated and the green light activated. Now you might think this is an absolutely insane way of doing things because you know, they could have done it in a much simpler way, but I think it's well, it's more generic. So what we could do is we could extend this implementation by having an amber light and adding an additional state. So one where we change from red to amber to green. Then we want when we want to go from green to red, we again have to transition through amber, and that would be a lot easier here. So we would just change some of the terms and find a different Boolean expression, but it'd be much the same layout. And again, that's the main reason. Well, the main point of studying these examples is that they extend to quite large simulations or designs, and they'll be very useful later on. So it's particularly important to understand the concepts between how these designs are constructed, so which sort of components they're made up from, and how you can see, well, and how they might scale. So have a good think about that, and then I think this is the last traffic light one, and we'll have a look at something a bit more complicated in the next video.